Exercise 2.1, question number 2, given integrate with respect to x 9x square minus 4 by x square whole square. This is the first type. Here we are using two formulas. One is integral x power n dx equal to x power n plus 1 divided by n plus 1 plus c, where n is not equal to minus 1. The second one, integral ax plus b whole power n dx, that is equal to ax plus b whole power n plus 1 divided by n plus 1 into a plus c. And then one another formula, integral 1 by x power n dx is equal to minus 1 by n minus 1 x power n minus 1 plus c, where n is not equal to 1, here n is not equal to minus 1. These are the formulas applied in the first exercise. So you should thorough these three formulas basically to complete the exercise 2.1. Now the second question is given as 9x square minus 4 by x square whole square. We cannot directly integrate this because we have square on the whole square is given, and also within the power we should have linear power. If we have linear power, we can directly go to the second formula, but here the powers are not linear, so you should expand it by a minus b whole square, then split into different functions, then we can integrate. For that, 9x square minus 4 by x square whole square equal to, this is in the form of a minus b whole square, expanding a square minus 2ab plus b square should be equal to 81x power 4 minus 72, this x square get cancelled, plus 16 by x power 4. Here this is equal to 81x power 4 minus 72 plus 16 by x power 4. So substitute here. Now integral dx. The function is in x, so we are substituting the integrand as dx. The function is in t, the integrand will be dt. This is equal to integral, instead 9x square minus 4 by x square whole square, you can substitute these terms, 81x power 4 minus 72 plus 16 by x power 4 into dx. Now listen here, 81x power 4, 72, 16 by x power 4 into dx. There are three different functions appear here. This is a constant function. When we differentiate x with respect to x, it is 1. When we integrate 1 with respect to x, it will yield x. So integral, so d by dx of x is equal to 1. So integrating integral 1 dx is equal to, taking 1 as the integral function, the function to integrate. When integrating, it will be integral dx, it turns as x. So integral dx appears, that is equal to x plus c. So integral 5 dx means 5x plus c, because 5 is constant, then integral dx is x. Oh, minus 3 by x, minus 3 by 2 dx will be equal to integral minus 3 by 2 dx is equal to minus 3 by 2 integral dx, that is equal to minus 3 by 2 into integral dx become x. So when we integrate all the constants, the x will be multiplied with all the constants, x will be multiplied while integrating. If it is dx, x multiplied by the constant. If it is dt, t multiplied by the constants. If it is ds, s multiplied by the constants. Now we are integrating now, which is equal to 81 constant, keep the same. Then x power 4, this is in the form of exponent dx, that is x to the power n plus 1, 5 by n plus 1, 5. Minus 72 is a constant. Here we have dx. So while integrating, it will be minus 72x. Then plus 16 into 1 by x power n. By use of 1 by x power n formula, minus 1 by n minus 1 x power n minus 1 plus c. So that is equal to minus 1 by n minus 1. N is 4. So n minus 1 means 3. X to the power 3 plus, for all totally we'll add a one constant of integration c. If possible, we can simplify this. 81 by 5 x power 5 minus 72x minus 16 by 3 x cube plus c is the integral value of 9x square minus 4 by x square whole square. Question number 3. Integrate the following with respect to x. 3 plus x into 2 minus 5x is given. If the functions combined with addition and subtraction, we can directly integrate all the functions consecutively. But the functions are in product, we don't have formula to integrate directly. So those type of cases, we should multiply the different functions and combine a single function. So multiply these two. Integral dx will be equal to, before entering in this, we should multiply the two terms, 3 plus x into 2 minus 5x. Multiply the functions given. 3 into 6, 3 into minus 5x minus 15x, 2 into x, 2x minus 5x square. Simplifying, we have 6 minus 13x minus 5x square. Now replace 3 plus x into 2 minus 5x as 6 minus 13x minus 5x square. That is equal to integral 6 minus 13x minus 5x square into dx, which is equal to, now we can integrate because the functions are combined by addition subtraction. Here 6 is constant. While integrating constant, if the integrand is dx, x will be multiplied with the constant. If integrand is dt, t is multiplied with the constant. So 6 into x minus, here 13 constant, x power 1, that is x power n formula chosen. For that, x power n plus 1 by n plus 1. So x power 1 plus 1, 2 divided by 2 minus 5 x square, n is 2. So again x power n formula, x power n plus 1 by n plus 1, x power 3 by 3. Totally we can add a constant for all the three different functions. Constant of integration c. That is the final answer. Therefore integral 3 plus x into 2 minus 5x dx will be equal to 6x minus 13x square by 2 minus 5x cube by 3 plus c. Question number 4. Integrate the following. Root x into x cube minus 2x plus 3. Here x cube minus 2x plus 3 is given. The functions are in product. We couldn't integrate directly. So we should multiply and combine a single function. For that, multiply the two terms. So integrate with respect to x. The functions are in x. So apply dx here. So multiply these two. Root x into x cube minus 2x plus 3. Root x means x power 1 by 2 into x cube minus 2x plus 3. When we multiply a power m into a power n, when the bases are equal, we can add the power a power m plus n. Similar to that, here x power 1 by 2, x power 3, while multiply these two terms, x power 3 plus 1 by 2 minus 2 into multiplying x power 1 by 2 into minus 2x minus 2 into x power 1, x power 1 by 2, 1 plus 1 by 2, then plus 3 into x power 1 by 2. This is the product of these two terms. Simplify the power here. X power 5 by 6 plus 1, 7 by 2 minus 2 into 2 x power 2 into x power 3 by 2 plus 3 into x power 1 by 2. This is the product of these two terms. When we multiply, we can add the power when the bases are equal. Here xx bases are equal, well, multiply, the powers added, and then here minus 2 into x power half, x power 1, x power 1 plus half, and then here minus 2 x power 1 plus half, then x power half into 3, 3x power half. Simplifying the power, we have x power 7 by 2 minus 2 x power 3 by 2 plus 3x power 1 by 2. Now replace this term by this term because both are equal. That is equal to integral x power 7 by 2 minus 2 x power 3 by 2 plus 3 x power 1 by 2 into dx. Now integrating. These are all in the form of x power and dx. Or 3 times apply the integral x power and dx formula here. That is equal to x power n plus 1 by n plus 1, 7 by 2 plus 1 by 7 by 2 plus 1 minus 2 constant. Then the x power 3 by 2 become x power 3 by 2 plus 1 by 3 by 2 plus 1, and then plus 3 into x to the power 1 by 2 become 1 by 2 plus 1 divided by 1 by 2 plus 1. Plus add a constant of integration to all the functions. A constant of integration for all the functions. Here, simplifying, we have x to the power 9 by 2 divided by 9 by 2 minus 2 x to the power 5 by 2 divided by 5 by 2 plus 3 x to the power 3 by 2 divided by 3 by 2 plus constant of integration c. Now bringing this denominator to the numerator, 2 by 9 x power 9 by 2 minus 2 into 2 by 5 x power 5 by 2 plus 3 into 2 by 3 x to the power 3 by 2 plus constant of integration c. Again simplifying, we have 2 by 9 x power 9 by 2, these two multiplied, minus 4 by 5 x to the power 5 by 2 plus 3 and 3 get cancelled plus 2 into x power 3 by 2 plus c. That is the required integral value of root x into x cube minus 2x plus 3 into dx. This is the final answer. Fifth question, example 2.1, exercise 2.1. Given integrate with respect to x, the given function is 8x plus 13 by root of 4x plus 7. We cannot multiply by anything, and we couldn't simplify these functions. Just adjusting the values, we can integrate easily. Now look at the numerator and denominator. The denominator we have 4x plus 7. The numerator we have 8x plus 13. In purpose to form the multiple of denominator as numerator, make a small change. 8x plus 13 can be converted into 8x plus 14 minus 1. Write this 13 as 14 minus 1. Now, remove 2 from common from these two terms. 2 into x plus 7 minus 1. 4x plus 7 minus 1. 8x plus 13 can be written as 8x plus 14 minus 1. 13 can be written as 14 minus 1. Now removing 2 as common from first two terms, it will be 2 into 4x plus 7. Now we are reaching the denominator function. So for that purpose we are writing this, just adjusting. So now integral dx is equal to, now apply the equivalent value to the numerator, integral 8x plus 14 minus 1 by it has power 1 by 2 because square root is converted as power 1 by 2. 4x plus 7 whole power 1 by 2 into dx. Now simplifying, we have integral, take 2 as common, 2 into 4x plus 7 minus 1 by 4x plus 7 whole power 1 by 2 dx. Now separating the denominator to each function, we have 2 into integral 4x plus 7 by 4x plus 7 whole power half dx minus integral 1 by 4x plus 7 whole power 1 by 2 dx. Now it has power 1, it has power half. When cancelling, we will have 2 into integral 4x plus 7 whole power half into dx minus 4x plus 7 whole power minus half into dx. We can convert this denominator to numerator, the power will be negative. Here applying ax plus b whole power in formula for both the terms, that is equal to 2 into ax plus b whole power and in the ax plus b whole power n plus 1 by n plus 1 into a 4x plus 7 whole power n plus 1 1 by 2 plus 1, that is equal to 3 by 2. So 3 by 2 divided by 3 by 2 into the constant with the x, coefficient of x is also multiplied with the denominator, minus for another function ax plus b whole power n plus 1 by n plus 1 minus 1 by 2 plus 1 equal to plus 1 by 2. So 1 by 2 divided by 1 by 2 into the constant with coefficient of x multiplied with the denominator plus constant of integration c. Now simplifying this, we can have these 2 and 4 get cancelled by 2. Now this 2 and 2 again cancel, that is equal to 4x plus 7 whole power 3 by 2 by 3. Here 2 and 2 get cancelled by 2 here. So minus 4x plus 7 whole power 1 by 2 by 2 plus c is the final answer. Look at the step here. 8x plus 13 is 14 minus 1. Then taking 2 common from these two terms only, 2 into 4x plus 7. Then separating the denominator, 2 into 4x plus 7 by 4x plus 7 whole power half. Then minus 1 by 4x plus 7 whole power half into dx. In this place I am splitting the entire fraction into two different fractions by using the two different terms in the numerator. Then only I am integrating. This will be easy when we convert two different functions while integrating. Question number 6, exercise 2.1, given as integrate with respect to x the given function 1 by root of x plus 1 plus root of x minus 1. 1 by root of x plus 1 plus root of x minus 1. Before integrating this, that is integral dx should be applied. This is a integral symbol and this is integrand. This is the required function to integrate. Here simplify this function by taking its conjugate. You are all familiar this type of simplification. Now multiply the numerator and denominator by the conjugate of denominator. 1 by root of x plus 1 plus root of x minus 1 into root of x plus 1 minus root of x minus 1 divided by root of x plus 1 minus root of x minus 1. That is equal to, the denominator is in the form of a plus b into a minus b. So a plus b into a minus b equal to a square minus b square. A square minus b square. So while multiplying the denominator, the root will get cancelled. The remaining are x plus 1 minus of x minus 1. A square minus b square. A square means root get cancelled, and b square root get cancelled. The remaining in between we have minus a square minus b square. The numerator we have 1 here, so multiplying we get the same term here, that is root of x plus 1 minus root of x minus 1 in the numerator. Just multiplying by 1 we will get the same values here. In the denominator we have a plus b into a minus b, a square minus b square is the product. Then multiplying a square minus b square will get so multiplying the square root will get cancelled, and minus in between the functions will appear. Here, simplify again. The root of x plus 1 means x plus 1 whole power half minus x minus 1 whole power half divided by, multiply this minus inside, it will be minus x plus 1. So x and minus x get cancelled. 1 plus 1 become 2. So we will have only 2 in the denominator. And simplify, we will get only 2 in the denominator. Now this function is equivalent to this function. You can write the whole workout here, or you can do it the right. You can substitute here. That is equal to integral x plus 1 whole power 1 by 2 minus x minus 1 whole power 1 by 2 divided by 2 into dx. This is equal to this term. So I am substituting the equal value here. Take out 1 by 2 and then integrate. There are two functions. One is x plus 1 whole power n, another one is x minus 1 whole power n. Combined by subtraction, we can directly integrate. Functions combined by individual functions combined by addition and subtraction, we can consecutively differentiate. Now the functions are combined by subtraction. So this one is ax plus b whole power n formula. Instead a we have 1, so we need not to multiply in the denominator as 1. Now ax plus b whole power n means ax plus b whole power n plus 1, 1 by 2 plus 1 by 2 plus 1 into 1. The quotient is 1, you need not to multiply. Minus x minus 1 whole power n plus 1 by n plus 1 plus constant of integration c. For all the cases, one constant of integration plus c is added. Now simplify here. 1 by 2 x plus 1 whole power 3 by 2 by 3 by 2 minus x minus 1 whole power 3 by 2 by 3 by 2 plus constant of integration c. Here simplifying this one, it will be 3 by 2, then 2 to get cancelled. Here also 3 by 2. Multiply 1 by 2 is common to both the terms. That is equal to, now taking 1 by 2 as common, 1 by 2 by 1 by 2, and remaining are x plus 1 whole power 3 by 2 by 3 minus x minus 1 whole power 3 by 2 by 3 are remaining. So plus c. So cancelling these two 1 by 2, will get x plus 1 3 by 2 by 3 minus x minus 1 whole power 3 by 2 by 3 plus c will be the final answer. Therefore, integral 1 by root of x plus 1 plus root of 1 x minus 1 dx is equal to x plus 1 whole power 3 by 2 by 3 and x minus 1 whole power 3 by 2 by 3 plus constant of integration c. Seventh question, exercise 2.1. Given f dash of x is equal to x plus b and f of 1 equal to 5 and f of 2 equal to 13, we should find the f of x. Now f of x is equal to integral f dash of x dx. F of x is equal to integral f dash of x dx. So f of x will be equal to integral f dash of x into dx. So required f of x will be equal to integral f dash of x. F dash of x is x plus b into dx. While integrating, f of x is equal to x power 1 means x power n plus 1 by n plus 1, x square by 2. Then this is constant, so constant is multiplied by x if it is dx. So bx plus one constant of integration c we have. This is the integral value of f of x. Now we have two constants b and c. To find those constants, they have given two informations, f of 1 equal to 5 and f of 2 equal to 13. Substitute in this case, f of 1 equal to 5 implies, substitute x is equal to 1, which implies that f of 1 will be equal to 5. So f of 1 equal to 1 by 2 plus b into 1 b plus c. Instead f of 1 we have 5. So 5 equal to 1 by 2 plus b plus c. Now 5 minus 1 by 2 equal to b plus c. 5 minus 1 by 2 equal to b plus c. Right here 5 minus 1 by 2 equal to b plus c. Simplifying this, 9 by 2 equal to b plus c. Let it be equation number 1. And then substituting another value, f of 2 equal to 13. When x is equal to 2, f of 2 will be equal to 13. Then x is equal to 2, f of 2 equal to 13. So substitute here, let it be 1, let it, this answer be 2. Substitute x is equal to 2, f of 2 equal to 4 by 2 plus 2b plus c. Now simplify this. F of 2 equal to 13. By substituting 13 equal to 2 plus 2b plus c. Now 13 minus 2, 11 equal to 2b plus c. That is equation number 3. By solving 2 and 3, we will get the values of b and c. Then substituting b and c in 1, we will get the required function f of x. 3 minus 2 implies equation 3 minus 2. 3 is 2b plus c equal to 11 and 2 is b plus c equal to 9 by 2. Subtracting, we are multiply by 2 the equation, you will get some equation that will be very easy to you. Now subtract b, these two get cancelled, equal to 11 minus 9 by 2. Now b equal to 22 minus 9 by 2, that is equal to 22 minus 9 by 2, that is 13 by 2. b equal to 13 by 2. Then substitute b equal to 13 by 2 in equation 2 or 3, that is in 3. Substitute b equal to 13 by 2 in 3. We have 11 equal to 2 into 13 by 2 plus c. These two get cancelled. 11 minus 13 equal to c, which implies c is equal to minus 2. Substituting b and c in equation number 1, f of x is 1 implies the required function f of x is equal to x square by 2 plus bx. b means 13 by 2x plus 13 by 2x plus constant of integration c. The value of c is minus 2. So the required function f of x is equal to x square by 2 plus 13 by 2x minus 2. Once I repeat the same question here. F dash is given, f of 1 and f of 2 also given. We should find the value of f of x. We have formula f of x will be equal to integral f dash of x dx. That is f of x is equal to f dash of x is given x plus b. Substituting here, the power of x is 1. So while integration, this is x square by 2. This is a constant, so multiplied by x because we have dx here. So b is multiplied by x while integrating, and one constant of integration will be added, that is c. This is the function f of x. Here two unknowns we have, b and c. We should find the values of the unknowns b and c. For that they have given two informations, f of 1 equal to 5 and f of 2 equal to 13. By substituting these two values in 1, now x is equal to 1, the total function f of 1 equal to 5. So substitute x is equal to 1 in all these cases. F of 1 then 1 by 2 plus b into 1 b plus c, and then this f of 1 will turn as 5. F of 1 equal to 5. Substitute f of 1 5, then remaining the right side same. Now 5 minus 1 by 2 equal to b plus c. 5 minus 1 by 2 b plus c. Simplifying 10 minus 1 9 by 2 equal to b plus c. The second case f of 2 equal to 13. Again go to 1. Substitute x is equal to 2 in all the cases. Now x is equal to means f of 2 equal to here 2 by 2 square 4 by 2 plus b into 2 2b plus constant c. Again f of 2 equal to 13, so this f of 2 is replaced by 13, and simplifying this 2 plus 2b plus c. Then simplifying this 13 minus 2 will be equal to 11, which is equal to 2b plus c. That is the equation number 3. And solving 2 and 3 will get a b and a c. Then substituting b and c in the equation 1 will get the required function f of x is equal to x square by 2 plus 13x by 2 minus 2. Eighth question, if f dash of x is equal to 8 cube minus 2x and f of 2 equal to 8, find f of x. Similar to question number 7, there we had two informations. Here we have only one information beyond the f dash of x. Now, to find f of x, we have formula integral f dash of x into dx. Substitute here. Therefore, f of x is equal to integral f dash of x is 8x cube plus minus 2x, 8x cube minus 2x into dx. Integrating f of x is equal to 8 into x power 4 by 4 minus 2 here x power 1, x power 2 by 2 plus constant of integration c. This is x power n formula, x power n plus 1 by n plus 1. And here x power 1, then x power n plus 1 by n plus 1. Cancelling these two here, they get cancelled. F of x is equal to 2x power 4 minus x square plus c. This is the integrated value. So f of x, we reached f of x as 2x power 4 minus x square plus c. But here there is an unknown constant. To find that unknown constant, they have given f of 2 equal to 2. Substitute here. Given f of 2 equal to 8, when x is equal to 2, f of 2 is 8, so put x is equal to 2 in 1 implies f of 2 equal to 2 into 2 power 4 minus 2 square plus c. So substitute f of 2 is 8 equal to 2 into 16 minus 4 plus c. So 8 equal to 32 minus 4 plus c. Here 8 equal to 28 plus c. Now 8 minus 28 equal to c. C is equal to minus 20. Substituting in 1, the required f of x is equal to 2x power 4 minus x square minus 20 is the required function f of x. Example 2.6. This is the only problem different from the exercise problem. Okay, all the other examples are related to exercise problems. Similar problems of exercise will be given in the examples. This is the only just a little different problem. That is approaching here 2x square minus 14x plus 24. Taking 2 as common, x square minus 7x plus 12. Factor it. By factoring, we have x minus 3 and x minus 4. X minus 3 and x minus 4 are factors. So, substitute in the numerator. That is equal to integral 2 into x minus 3 into x minus 4 divided by x minus 3 into dx. We can cancel x minus 3 and x minus 3. The remaining are 2 into integral x minus 4 into dx. Now integrating, we have 2 into, this is x square by 2 minus 4x. Then multiply 2 inside, that is a constant of integration plus c. Then multiply 2 inside, we'll get that is equal to x square minus 8x plus constant of integration c. That is the required integral value. Very simple, just factorizing the numerator and cancelling with x minus 3, integrating the remaining function. That's all.